Hey, 7th grade. Today we're going to be moving on to lesson 3 in chapter 13, rotations. So we've been working on transformations in this chapter, and this one is going to be our third transformation. So the first one we did was translation. So that was when we had a figure and it slid, right? It might have gone to the side, it might have gone up, but it just slid, right, on a coordinate plane. And then the second one was reflection. So we had our coordinate plane and then our figure reflected, right? It flipped, okay? So the word for that one is flipped. Today, our word is turn. So we're gonna have a figure and it's gonna turn, it's gonna rotate, okay? So it's just, we're gonna be talking about like quarter turns, half turns, 3/4 turns. So 90 degrees, 180, those are going to be the main, okay? So we're going to, today, if you have graph paper, you're going to want to use it. So if you need to pause it to go find some, you should. And also, we're going to need, well, it's going to be easier if you have a triangle. So I just found a piece of white paper and I ripped the corner off and then I just cleaned up the rip. I, cut right there, but it's just the bottom of a page. And you can use any size. You might want to watch the notes first and then go back and try it on your own or with me, play my notes again. Because rotation it's definitely not the hardest, but it's really hard to visualize. It's going to be easier if you actually try it with something. Okay, so that's my recommendation, is to definitely don't get lazy, do it. Okay, it's like an experiment. It's kind of sciencey. So rotation. The definition is that it's when a figure turns about a fixed point. Okay? The point, that fixed point, this that we're talking about right here, is called the center of rotation. These are all the highlighted words in your lesson. Rotational symmetry is when a figure, when rotated 180 degrees, exactly matches the original shape. So we're going to be working mostly with coordinate planes, right? We've got the X and the Y axis, but it doesn't just apply to coordinates, okay? So if you look at A, this is what an A looks like when you start, okay? If you're to rotate it 90 degrees, this is what it looks like. If you were to rotate it 180 degrees, it's upside down, so it does not have rotational symmetry. This does not look like this. And then lastly, if you rotate it again another quarter, you get our 270, right? 270 degree turn. And then if we turned it one more time, one more quarter turn, we'd be back where we were, a complete 360. Okay, it went all the way around. Rotations in this book are counterclockwise, which I generally try to do to the right, clockwise. So I would get everything wrong if I didn't double check. So this would be something like, if I was you, I would highlight this counterclockwise. Everything's going to be going reverse. You can find the angle of rotation of a figure using a fraction and 360. Since 360 is a whole turn, you can find out how far something needs to turn before it will line up and be rotational, have rotational symmetry. Okay, so we're going to try one like that. This is a poorly drawn flower, okay, but you get the idea. It has 5 petals that are all similar. We're going to pretend they're exactly the same because I enjoy math and not drawing so much. If I had a line of symmetry, if I cut right down there, I would have the same thing on both sides, right? 2.5 petals and then half the middle. I could go in several directions and create that same half down the middle, 2.5 petals. In fact, each petal, oops, went off a little bit on that. Each petal has its own that it cuts through on the opposite side. Oops, this goes this way. Sorry, on my pencil marks. So this, in fact, has 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. Different lines before we come back on itself. So we would turn that into a fraction because there are 5 petals and 5 lines of symmetry. That will be our fraction, and we'll multiply it by 360 degrees. 360 over 5, when we divide, 5 goes into 36 7 times with 1 left over. So that would be 72 degrees. 72 degrees. So the angle of rotation is when you find out how many lines of symmetry, you turn that into a fraction by putting 1 over the top, and you multiply that by the 360, a full turn. Okay? The example that they give you in the book is if your book is open to page 505, it's a symbol that has 5 lines of symmetry as well, so it's the same one. And then the different ones they're in your homework, so I don't want to give any answers away. You can have no lines of symmetry. If there's no lines of symmetry, then there's also no angle of rotation. Okay, so if there's no lines of symmetry, then there is no angle. This is my picture of an angle because I don't want to run out of room. Rotation. So, you know, if we were to pick, let's see, when we did names, right? The letter R. There's no line of symmetry in R. Therefore, it doesn't matter how many times we turn it, unless we do a full turn, that's the only time it's going to be on top of itself. It's the only time it's going to match completely. Okay? All right. This is where your graph paper is going to be important. Okay? So I took my graph paper and I folded it so that it would make 4 even coordinate planes for myself, right? So I folded it into 4s. And then I counted that I had about 20 going across, so 10 all the way down, 10. So 4 very similar quadrants. Go ahead and pause this and set up a piece of paper similarly. Again, this might be something you want to watch first and then go back and do yourself. That's fine with me. It's the example number 2. It's from your book, okay? But I want to show it to you. All right, so here we go. This is my triangle. I am going to call this triangle my initials. So K, C, L. Okay? And in the book, they use ABC, but they start, and it's not going to be exactly the same, but it will be similar enough around here with their triangle. Okay, so if I'm going to draw it just so that I've got it. Trying to keep my lines as straight as I can. All right, so there's my triangle, right? This is my starting point. This is the image that they've given me, okay? So, and then I'm going to mark it K, C, L. Same order as I did on my triangle, okay? So now I'm going to rotate it 90 degrees. So that's a quarter turn, right? So if I say K, right, my first name starts with K, so that's my first letter that comes in the triangle. K is in this bottom right coordinate, right? This is in this quadrant down here. So K will need to move a quarter and to the left, right? We're going counterclockwise. So that means K, since it's down 1 and over 1, will need to go up 1 and over 1. Okay, so K is my fixed center, right? Your fixed point. It's the one that everything else follows. So I've got this, and it's gonna rotate 90 degrees. So it has to do a flip. So this is where you're gonna have to, this is where it's helpful, right? If you have one, to trace it and actually be able to rotate it. Okay, so my L was 1, 2, 3, 4-ish, right? So it's down 2 and over 4. Down 2, over 1, 2, 3, 4. So from here, that means I want to go down 2 to the left 2 and then over 4. So 1, 2, 3, 4. This is going to be my new L. And then whether you go from L or back to K, K is your fixed point, so you should go back to the original. K is to C is up 1, 2, 3, 4, 5, 6 on mine, and then over 1, 2, 3, 4. So that means from here, right? And again, I have this, right? So I can cheat a little bit by making sure I'm in the right area by using my image, my copy. So now I want to go over 2, 3, 4, and then up 4. 1, 2, 3, 4. And that's going to put me right here. So now this, C, is my new image. Okay. And because this is an image, right, this is K prime, L prime, C prime. Okay. This is my original. How do you guys feel about that? All right. Let's do another one. Okay. So going back to the original, I'm going to put it back where it was. We've got it's not big enough. Here we go. Here's my original triangle, K, C, L. And now I want to rotate it 180 degrees. So it's going to do a half flip, not a quarter, not a whole, not 270, right? It just half. So that means, right, if this was the quarter up here, over and down, and then over and up, now I'm going to do 180 is going to jump to this quadrant. So it's over and up, and here is my K prime. Okay, so this is going to rotate here